Hello students, I am Dr. Smita Pillai, Associate Professor, Department of Commerce, Bhopal School of Social Sciences. Today we are going to study another algebraic method of interpolation and extrapolation, that is Newton's advancing difference method. So Newton's advancing differences or forwarding differences is applicable where independent variable x advances with the equal intervals. That means 5, 10, 15, 20, 25. These are advancing with the equal intervals. Now we can interpolate or extrapolate any value using this method, but it gives best results when interpolation needs to be done near the beginning of the values. Okay, this needs to be taken care. Now next is also this method is applicable where independent variable x for which y has to be interpolated should not be one of the limits, should not be one of the class limits of x variable. So look at this, if this one is taken as x, now here we can interpolate for 7, which is not given here. We can interpolate for 12, also not given here. We can interpolate for 17, which is not given here. Any value which is not given here can be interpolated, unlike in the case of binomial expansion method. This is the major difference between binomial expansion method, application of binomial expansion method, and Newton's advancing difference method. So let's understand the formula for using Newton's advancing difference method. When you look at this formula, it looks so complicated, but very easy to understand and develop this formula rather than by hearting it as it is. Now yx is equal to y0 plus x del 10 plus x into x minus 1 del 20, 2 factorial, then x into x minus 1, x minus 2 into del 30, 3 factorial, then x into x minus 1, x minus 2, x minus 3 del 40 by 4 factorial, and so on. So this is the formula for Newton's advancing difference method. Now let's see the procedure for calculating the Newton's advancing difference formula. So the x variable is denoted as x0, x1, x2, x3, etc., xn, and the notations provided to y variable are y0, y1, y2, etc. till yn. So the value of x can be calculated using the formula the value to be interpolated minus the value of x at the origin and the difference between two adjoining values of x. Let's see with this example. X is given as 5, 10, 15, 20, 25, and we are asked to find out value in between this, that is for 70. Okay, so we are asked to interpolate for 70. Now here the notation that we use for this is x0, x1, x2, x3, x4, and so on. And then here if you look at xx, what is this xx? That is the value to be interpolated. Here it is 17. So we will be writing 17 minus x0 means the value of x at the origin, that is 5 divided by the difference between two adjacent values, x0, x1 minus x0. Okay. So the difference between x0 and x1 or x1 and x2 can be taken here because all the values are of equal intervals here. So here the difference between these two are 5. Okay. So I hope you understood this. Xx minus x0 is the value of x at the origin, and then you have to take the difference between two adjacent values of x. After finding out the value of x, the next step is to prepare the table of differences. Okay. Now here in table of differences, to calculate the differences, every preceding value of y is subtracted from the succeeding value of y variable. Okay, and the differences thus arrived are known as the first leading differences and denoted by del 1, del 10, del 11, del 12, etc. and pronounced as this is to be pronounced as delta. Okay, so on the basis of first difference, we calculate the second difference, which are known by del 20, del 21, del 22, etc. And this process is followed till it remains there only one difference. Okay. Now the procedure of finding advancing differences can be understood from this table. Okay. Now independent variable, x0, x1, x2 and x3. Dependent variable y0, y1, y2 and y3. Okay. Now the first leading difference. So you have to take the difference between y1 minus y0, that is del 10. Then y2 minus y0, that is del 11, and y3 minus y2, that is del 12. So how do we make this? How do we understand this del 11, 0, 11 and all? See, the first one is del 1. So here the entire this one remains del 1, del 1, del 1. Okay. Now the first is 0, then 1, then 2 and so on. So it is very easy to understand the notation. Okay. There is no need to by heart this notation. Rather you can look at this one. This is del 1 column. So del 1 remains same. Then the subscript will be 0, 1, 2 and so on. Right. So here we take the difference between two adjacent here, y1 minus y0, del 10. The next is y2 minus y1, del 11, and then the next is y3 minus y2, that is del 12. So that's all for the del 1 column. Now we are moving to the second leading difference. Here del 2 column will start. So this is del 2. So del 2 will remain here, and then you have to change the subscript. As many number comes, as many differences comes, that many times you have to change this one from 0, 1, 2 and so on. So here 3 numbers are there. So we start from this one, del 11 minus del 10. Okay. Then you will get del 2, 0, the first one, first difference of del 2. Then del 12 minus del 11, you will get the second difference of del 2. Now here only 2 are left. Okay. So del 11 minus del 20 will give you del 30. So here only 1 remains. That means we end there. So we have to proceed till only one difference is there. Attention should be given towards the mathematical sign plus or minus while calculating the advancing differences. Otherwise, a single mistake will give you wrong answer. Look at here, when we take y1 minus y0, so you may get a negative value or a positive value. So that negative sign should be taken care in each differences. Now the formula is extended till last advancing difference. Look at here, so only 1 is remaining here. So we have to leave till it reaches to only one value. Let's understand this with the help of this practical. The following are the annual premium charged by an insurance company for a policy of rupees 1000 and calculate the premium at the age of 26. So here age in years are given, which is X, and premium are also given, which is Y. We have to interpolate for X is equal to 26. Okay, this is to be interpolated. Now look at the solution of the same. Age in years, the notations are x0, x1, x2, x3 and x4. Now next is premium in years, y0, y1, y2, y3 and y4. Okay, so now we have to take the differences between the two adjacent this one. That means first leading difference, second leading difference and so on. So we are starting with the first leading difference, y1 minus y0. That means 26 minus 23, that is 3, 30 minus 26, 4, 35 minus 30, 5, 42 minus 35, 7. Okay. So all these are plus signs because succeeding values here all are greater numbers, bigger numbers. So obviously you would be getting a plus sign here. Otherwise you have to take care of the sign. If suppose 26 is above and 23 is here, so then of course it will be a negative value. So you have to take care of that. Now here del 1 is completed. So you have to start with the subscript here 0, 1, 2 and 3. Okay. Now del 1 0, del 1 1, del 1 2, del 1 3 are the first leading difference here. Now let's move to the second leading difference. Second leading difference are calculated by taking the difference between del 1 1 minus del 1 0, then del 1 2 minus del 1 1 and del 1 3 minus del 1 2. So you look at here, del 1 1 minus del 1 0, 4 minus 3. 4 minus 3 is plus 1, 5 minus 4 plus 1 and then 7 minus 5, it is 2. So we got second leading differences 1, 2, 1, 1 and 2. Okay. So let's move to the third leading difference now. Third leading difference, del 21 minus del 20, 1 minus 1, that is 0. Del 22 minus del 21, that is 2 minus 1, 1. So we have completed with the third leading difference as well. Now we are moving to the next fourth leading difference. We have to lead till it reaches to only one value. So here 3 1 minus 3 0, del 3 1 minus del 3 0, 1 minus 0. 1 minus 0 is plus 1. Okay. So only one number, only one difference is there now. So there is no need to take the difference. We cannot take the difference further. So you have to advance till it reaches to one value. So we have to end it here, del 4 0, right? After finding the leading differences, now we have to substitute these values into the formula. So here, if you look at this formula, y26, if we have to interpolate for 26, then y0 plus x into del 1 0, x into x minus 1 into del 2 0, x into x minus 1, x minus 2 into del 3 0, it advanced like this. So look at this one, this is x, next one, in the next term it will be x into x minus 1. In the third term, it will be x into x minus 1 into x minus 2, then x into x minus 1, x minus 2, x minus 3 and so on. So here del 1 0, so we have to take up y 0, del 1, del 2 0, del 3 0, del 4 0, all the first values have to be substituted here. So y 0 is 23, del 2 0 is 3, del 1 0 is 1, del 3 0 is 0 and del 4 0 is 1. So here if it is del 1 0, so you have to write here 1 factorial. If it is del 2 0, then the denominator is 2 factorial. 2 factorial means 2 into 1. Okay, you can write 1 into 2 also. If the next one, if here it is 3 factorial, so 3 factorial means 3, 2, 1. 4 factorial means 4, 3, 2, 1, etc. Okay, so this way we have to substitute the values. After substituting the values in the formula, we will get 23 plus 1.2, 1.2 is x, okay, 1.2 into 3, 3 is del 1 0 is 3, del 2 0 is 1, then all these values we have to substitute and then we will find y26 is equal to 23 plus, here when you multiply these two you will get 3.6. So here 1.2 into 1.2 minus 1 divided by 2. So it is 0.24 divided by 2. Here no need to multiply because we multiply all these. We know that it is finally getting multiplied with 0. So it automatically becomes 0. And then next is when we do the calculations here, 1.2 into 1.2 minus 1, 1.2 minus 2, 1.2 minus 3. Then we multiply, we will get 0.3456 divided by 4 into 3 into 2, that is 24. Okay, you have to take care of the denominator as well. So after this calculation we will get y is equal to 26.7344. We can round off to 2 decimal values. So we can write the premium to be paid at the age of 26 years is 26.73. I hope you understood this very clearly, and we will meet again with another lecture on interpolation and extrapolation. Thank you.